It's just weird, yeah, and it really is just tedious.
Hate.
Okay, so 30 is dy dx is equal to y. Now, they give us, so they say in the instructions, construct a slope field for the differential equation in each case, copy the graph at the right, and draw tiny segments through the 12 lattice points shown in the graph. Use slope analysis, not your graphing calculator. So they give us, well, I'll do it over here. So then I can do any work that I don't really need to do work for this one, but it's fine. Come on. So they give us, it goes up to, so there's at 1 and at 2 and at -1. And then on the zeros, and they go out to 1 and -1 on the x-axis. So this is what it looks like, and then they're wanting you to draw lines through each of them.
Oh, so you like draw lines with the dots?
Yeah. This point's really annoying me. It's like
I
not.
don't like how it, I know it's less work, but I don't like how it doesn't go to 2 for all of them.
Okay, so now we need to look at the slopes for these. Now, because this is a y one, that means in each row, everything going across is going to be the same because there's not an x and a y. There's just a y. If it was just x, remember, it's the ones going up and down that are the same. So, if I did, let's start with the easy one, 0, 0. Okay, so when y is 0, what is the slope? 0. So then y is still 0 at 1, so still 0 at -1. Then when y is 1, what's the slope? 1. So there's no x, so that doesn't change anything. We just are looking at the y value. When y is 2, what's the slope? So it gets a little steeper. When y is -1, what is it?
Wow, guess.
-1. And that would be all you need to do for that. Now, for these ones, you won't really need any work because you're just basically just looking at that. This next one, we will need to have a little bit of work for, or it'll probably be beneficial to show something. 32 dy dx is equal to 2x minus y. And it's the same like axis, so if you want to go ahead and draw that. Just so y'all know, on like the quiz or whatever, I'll probably just tell you on the y to go from -1 to 2 and on the x to go from -1 to 1. Like, I would just type that out and not actually draw it for you, and you'll just know to put one on each of the points. But she got an email from College Board that says the countdown to the exam has begun. I was like,
Wait, I do have a question. When do we pay for these things?
like the week before.
Okay. Just make sure.
Yeah, they'll just collect everyone. Some, like, in the past, what we've done is we've just said bring it to the exam, but a lot of people forget, so
Bring what to the exam?
the check. But, like, if you're taking 3, you can write that all. It's going to the school because the school's paid for it up front, and then y'all are just reimbursing the school, basically. Okay, so let's do a table on this one just for practice. So we'll do x, y, and then 2x minus y. And we probably don't necessarily need a table for this one because I think y'all could probably kind of do this in your head, but, you know. All right, so let's start at -1, -1. Let's do -1, 0, -1, 1, -1, 2. Let's do those ones, and then we'll go and do the next row of them. All right, so when I do -1, -1 into this equation, what do I get?
Yeah, -1. Negative.
Wow. When I plug in -1, 0, what do I get?
Yeah, -2.
When I plug in -1, 1, what do I get?
Wait. Negative.
When I plug in -1, 2, what do I get?
0.
So I would say go ahead at this point and let's go ahead and do the slopes for these. So at -1, -1, it's a -1 slope. At -1, 0, it's -2.
Wait. For the -1, 2, when we get -4.
Probably. I'm just going with what everyone said. -2 minus 2 would be -4, yeah. So notice every slope on this one gets a little steeper. So, I mean, make it look as much a little steeper as possible. Oh, that was not what I wanted to do. All right, and then let's do 0, -1, 0, 0, 0, 1, and 0, 2. So 0, -1 gives us 1.
3.
0, 0 gives us 0, 1 gives us 0, 2 gives us.
Bro, I don't know how.
All right, so at 0, -1, we have a slope of 1. At 0, 0, it's a slope of 0. At 0, 1, it's a slope of -1. 0, 2, it's a slope of -2. All right, and then we've got 1, whoops, 1, -1, 1, 0, 1, 1, and 1, 2. So when it's 1, -1, what do we get? 3, 1, 0, 2, 1, 1, 1, 1, 2, 0. So at 1, -1, it's a slope of 3. At 1, 0, it's a slope of 2. 1, 1, it's a slope of 1. And at 1, 2, it's a slope of 0.
How much is really care? I mean, it's
Yeah.
gonna be a swirl.
Well, probably what we would find more than likely is that it'll end up doing something like that.
Props.
Maybe, maybe not. I don't know.
Frogs.
Okay. Have I given y'all any problems with any of this stuff so far?
Yeah.
Oh boy, okay.
Oh.
Oh dear, wait. There's one more thing we need to. Oh dear. I lied. We're not done yet. We need Euler's method.
Oh wait, how was that? That was even in the title. I forgot.
He's not done with the session, so he's not.
What does Euler have to do with? Is it a whole new thing?
Not really. It's not too bad.
We get the E from this guy?
Yes.
Oh, I thought you. Oh, I didn't know what you said.
Why'd you think of-
Oh, I spelled it like
No, why'd
oil
you
again.
think
I
of
spelled it like oil again. He said get the E from this guy.
Oh.
Alright. Euler's method is a clever application of local linearity to graph a solution without knowing the equation. Do y'all want to write the steps or just have them referenced in the book?
Right. I absolutely realize it.
Okay.
It helps. It helps.
No one else
Well,
is.
you don't have to write it if you don't want, Ethan.
Yeah, you don't have to write it if you don't want.
Okay. The steps are on page 329 if you're just so inclined. Begin at the point xy specified by the initial condition. That point's going to be on the graph, just so you know. I'm not going to write that, though. Use the differential equation, I'm abbreviating that D, to find the slope dy dx at the point. Three, increase x by a small amount. Call that delta x. Increase y by a small amount. Call that delta y. Where delta y equals dy dx delta x which defines a new point x plus delta x, y plus delta y that lies on the linearization. For using this new point, return to step 2. repeating this process constructs the graph to the right of the initial point. And before you get alarmed, we're not actually graphing anything.
Oh, cool.
We're just finding the points. 5. To construct a graph moving left. To construct. I don't know what I'm saying. To construct a graph moving left from the initial point. Repeat the process using negative values for delta x. So we'll do 2 of them. We'll do different increments. So like 51 through 54 use the same delta x and x value. 55 through 58 use a different one. So we'll like do one of each of them. Just because these are also quite tedious. 54. And you're going to want 1, 2, 3, 4, 5, 6 lines.
Thanks.
54. dy dx equals 2x minus y. Y equals 0 when x equals 1. They tell us in the instructions that delta x is equal to 0.1 and x is 1.3. So we're using the 0.1 to approximate the value of y when x is equal to 1.3. So we're going to be doing basically 3 points. So we make this lovely table, which will make your life easier, which is we do the xy point right there. Okay. We're going to have dy dx is equal to 2x minus y. So that's where we're going to be plugging the numbers in. Then delta x, which is going to be the same thing all the way down. Delta y is dy dx times delta x. So we're going to take the dy dx value that we get in this column and multiply it by the delta x here to get this one. And then the final column, we're going to do x plus delta x and y plus delta y to get our new xy pairs. And that will, the y plus delta y of the final one, when x is 1.3, will give us our answer that we're looking for. So, well, maybe not. Come on. I know that's not straight, but it's whatever. Okay, so the first point is going to be 1, 0, because that's what's given to us. X is 1 when y is 0, or well, vice versa. So 1, 0. Then 1.1. When I put in 1.1, wait a minute. let's work our way across, and then we can't get this number yet because we don't. I'm trying to give you a number we don't have yet. All right. I was like, wait a minute, because I can do the x values, but I can't do the y values yet, because in every case we're adding like 0.1 to the x value. So like the third one will be 1.2, but we haven't found the y value yet. That's why we can't do it. Okay, so when I plug in 1 and 0 for 2x minus y, what do I get? 2. Delta x is always 0.1, so if you want to go ahead and write that in all the way down, that's the case. So then here, I take the dy dx value. So this column 2 times column 3 is going to give me the answer to column 4. So what is 2 times 0.1? 0.2. So then over here, x plus delta x, so this is where the 1.1 comes in, okay, because 1 plus 0.1 is 1.1. Then y plus delta y, so y was 0, delta y is 0.2, so this is going to be 0.2. So now we take this and we copy it down over here, so that's where the 1.1 and the 0.2 are going to come in. Is we had to have that to be able to do the next part. So if I plug in 1.1 and 0.2 for x and y in that equation, dy dx, what do I get? 2. Then dy dx times delta x is still 0.2. So x plus delta x, so 1.1 plus 0.1 is 1.2. Then y plus delta y is 0.2. Where is it? 0.2 plus 0.2, so 0.4. So now I use this point over here. What's 1.2 and 0.4 plugged into that equation? 2. And I'm just going to tell you that's not always going to be the case that they're the same. Then 0.1. So we've already said that's going to be 0.2. So over here, 1.3. So that's x plus delta x. And then y plus delta y. So 0.4 plus 0.2 is 0.6. And that's where we're trying to get to. We want to know what y is when x is 1.3. So that would tell us, without knowing the equation, f of 1.3 is equal to 0.6. And that would be the answer for that. So you don't necessarily have to do the table, but it makes it easier.
Yeah.
All right, let's do one that's a negative one. 56. dy dx is equal to 1 plus y. Y is equal to 0 when x is equal to 2. And this time in the instructions, they tell us that delta x is negative 0.1 when we're going to find y when x is equal to 1.7. Okay, so we're starting at 2 and we need to get to 1.7.
So we basically need to go down.
Basically, yeah, that's what we're going to be doing. So I'm going to set up the table the same way. X, y, and dy dx is equal to 1 plus y, delta x, and delta y is dy dx, and times delta x, and then x plus delta x, and y plus delta y. Now obviously our delta x value is negative, but we still leave the formula the same, and we just know that we're subtracting off 0.1 every time. All right, so we start with the point that's given, so 2, 0. If I plug in 2, 0 to the equation, what do I get? 1. And all the way down, delta x is going to be negative 0.1. So what's 1 times negative 0.1? Negative 0.1. So then x plus delta x, so that's 2 minus 0.1, so that's going to be 1.9. And then y plus delta y, so that's 0 minus 0.1, so that's negative 0.1. So then we bring that point over here. So if I plug in 1.9 and negative 0.1 to this equation, what do I get? 0.9. Then delta x is still negative 0.1. What's 0.9 times negative 0.1? Negative 0.09. So then the next point is 1.8, and negative 0.1 minus 0.09 is negative, backwards, 1.9. And then bring that one down, 1.8, and so this will be the last one because I'm just trying to get to 1.7. When I plug this in for y, what do I get?
Negative 0.7.
1 minus 0.19 is 0.81. Then negative 0.1. dy dx times delta x. So 0.81 times negative 0.1 is, you may not know this, negative 0.081 just for the sake of time. So then our answer over here is 1.7, and this number where we have y plus delta y is going to be negative 0.271. So answer is f of 1.7 is equal to negative 0.271. So I've really not given y'all any questions at this point. Okay. I'm going to say out of 1 through 9, pick 2. I don't care which ones you do. They need to be odd ones. 11 through 20, same thing. Pick 2 odd ones. 21. 31. 53 and 55.